Hey guys, welcome back to the channel. I have another interesting video. Well, this is part 2 for Eric Youssef in California with his MEFI 4 Volvo Penta 5.0 GXi-E. He's concerned, no fuel pump. So I was actually already recording the video, but I'm trying to get you a very good capture on the microscope, but it freezes, and I've been trying to make it work. So hopefully this time it does. So his concern is no fuel pump relay. We can see here, no light. That's it for the fuel pump. And you will see that on the other computer that I'm going to check. Let me move you over to the display so you can see what I have in here. So on the display right now, I have one of the known good captures that I have from another computer that I've been using as the guinea pig to get all this information. And on the left side, you can see the driver completely exposed, so I can see all the paths and everything to see if you have a broken path or what is the problem with his computer compared to a good computer. That's how I do it, and that's how I gather all that data. All those marks and everything you see there is made by me. So this is my personal information that I always gather myself, and I take the time to do that. So when I visit another computer, I have all that information. So waveform 1, 2 to 6 are these waveforms. So if you see the picoscope up in the tab, it says picoscope 7 automotive, waveform 5 on image for fuel pump relay driver with black triangle. So I remember when I was doing, or when I check another computer, what I was doing in here. So this is just the on and off of the fuel pump being commanded by either the scanner or me turning the computer on and off. But in this case, it's with the scanner. So that is ready. I don't need to have this in there for now. Well, let me show you, or Eric, that is your computer in there. So it's a little bright in there, but hopefully I can get to the actual microscope. And yeah, so far it's good. It's live. So this is what I want you to see. So it's going to be a little hard to show everything because I don't have Let me pause the video 1 second, guys, to see if I can get the picoscope in this capture as well. All right, I think I got it. And yeah, the signals are still, or the cameras are still recording. All right, so that in there is a known good waveform. So this is the on and off, and this is the way it should look. If I go over to this part in here, so let me carefully touch in here. All right, so I am now, as you see, touching the signal going into there. So I'm going to now run the oscilloscope. On. It's not working. All right, let me try to see what is going on. Well, it makes sense because what I was touching it was the image and not the actual recording. So yes, right now we have that in the way. I'm not sure why is this coming over. Because yeah, what I see the window is not good for you guys in there. So I can see it in there. I just needed to unfreeze it for a second, and then we can all see what I'm going to do. So just bear with me 1 second, guys. Trying to again give you the best possible capture. So you see what I'm touching in there. I'm going to run now the oscilloscope. And let me get this out of the way. Now it's no longer in here. All right, let me try it again because I just dropped the connection or my finger in there. I'm going to actually go over to the actual driver in here. So we can see the signal right there. So let me move my hand because I'm in the way for the camera. Okay, you guys can see what I'm poking in there. So this is the activation for that relay. So I'm going to just let it run for a little bit. I'm going to stop the capture and we're going to do a zoom. So let me just move that from there. And I'm going to show you as quick as possible because we have a lot of it's a huge amount of captures in order to get this signal to show, but you can see it's an on and off signal right in there where I am touching the computer, right? So that same signal is right here on the next pad. Let me just need to focus this a little bit for me to see. So give me just 1 second, guys. I'm trying again my best. All right, so the reason I'm not showing it is because I got to zoom, but I just moved my lead. This is what I don't record sometimes. This because it's very hard to show all this in tests. All right, so as you can see, I'm touching the very thin line right next to the big one, which is the signal coming, as the control for that relay. I'm going to stop now the waveform and go back to, well, actually, it's only one waveform because of the amount of sample rate that I have in there. So let me just run it a little more. Okay, I can stop it now. And we're going to do the same thing, do a zoom. And I'm going to show you that that is exactly the same signal. Just bear with me because it's so big, so much information in here that the computer needs a little bit of the software, not the computer, needs a little time to understand and process all that, right? Yeah, so as we can see, that same signal is right there. Okay, and this is normal. So that signal should be there. If I take you over to the image that we saw before, that is what I put waveform for. So, and if I open here, let me just show you. Oh, that's not what I need to do. So cancel. I need to open waveform four. You see right there is that is the waveform 4. So that is exactly that same signal. It's a 0 to 5 volts square waveform, and that is in there, and it's supposed to be there, but not on the activation of the relay. The funny thing about this situation with his computer, let me go back to now the actually I think I can do it on a 9 here. I'm gonna have to come in here. Let me move you over to here. So with the computer running, if I disconnect the wire from the relay and I touch it, you see that right now? The light is on. So it's now commanded the relay on. But it's because of that signal in there. And realistically, it's not happening, but it will happen. If I turn now this off and turn it back on and run the computer, it's not there. So it's for like a brief of a second, they actually, by me doing that, it's kind of like excites and cuts that signal and engages the relay. Obviously, you cannot do that on the boat. But what is this also telling me? Okay, well, the problem is it's not a shorted line because we have a diode for protection in there. It's actually a problem on that driver, and that driver is a crystal driver, not replaceable. So let me switch the computer. So let me move you over to here. Okay, as you see, well, you're not seeing in there, but we lost the communication, and you will be able to see that that's the diagram trying to synchronize the connection that I just turned everything off, right? All right, so and let me again disconnect this computer. So everything is now power off. Sometimes these connectors skip the inner part. That's what I got that plier here because they are swollen and that piece needs to be there. So this is Eric, and I'm going to cover and put it here. So I'm not going to take it away from the video yet. All right, so let me get mine is what I do with it. Move it away. Is this the one? Oh, this is CO. This one. I got a whole bunch of them. No, but this is I don't think this is the one. With a computer. Let me just double check. Oh yeah, this is it. All right, so this is another computer. I'm going to move the microscope camera just a little bit so you can see. Eric, that's yours, and this is the one I'm going to put. No matter what, Eric is not working properly, right? So we will see that. So I'm going to plug this computer here, and we're going to do the same test. I like to do this so I can show the customer and show you guys a little bit more of what I do here and behind the cameras, right? All right, so let's go back to the microscope. And yes, this is still connected, so everything is working good. So let me put that same spot in the screen so we can see everything. All right, let me, before we go there, let me go back to the main cameras. And let me show you the fuel pump. So just watch yourself in here. So computer is on. I'm going to keep my finger in there so you can see it. I'm powering on. And you can see fuel pump on and then off. That is the fuel prime. So that is normal as the way, like in all automotive, does the same thing, right? So it's a prime to prepare the fuel pump and all the system to start, right? All right, let's go over to the amp scope, the microscope. Yes, we're live. Perfect. Everything is working good. And we're going to do the same test. All right, so we're going to go over to the same section, which now you know that we can even poke in there or in the so first I'm in the big pad. I need to put this on here. Yes, you guys are watching that. And we're going to well, I need to change the waveform to open, and we're going to move it into here, right? So I get all the same settings, and that's the reason I'm doing that, to keep the same settings exactly as it was before. All right, so we got the on and off activation. All right, so we're going to run it. And as we can see right now, there is no fuel pump activation. All right, so with no fuel pump activation, that's the way it should look. I'm going to go behind the scenes, going and connect the computer to the scanner, and I'm going to do the on and off on the fuel pump. So fuel pump on, you can see it right there, and off. This is a test. It does it for like a second. I'm going to let the screen roll a little more, but we only see a portion of that in there. I did it twice in there. So if we go back to, or I go back to Pico, I just stop the signal so I can remove my hand from the computer. And let me go back. Oh, I lost it. So let me run it again. Well, you guys saw exactly what I see because it's a little hard to poke and do all the stuff in there. But with the same ignition on and everything, we get a nice and clean signal. Right there, we got the 12 volts. There is no that noise that we have in there from the driver itself, right? Because if I touch that little, remember that little pad that is next to that big one, is still here, and it's on. Let me make sure I'm touching it correctly. I'm trying to see through the microscope and get you guys the best capture possible. Now let me make sure it starts. So we can see that in there. So I'm going to stop the capture right there. I'm going to remove that so I don't short anything on my good computer, right? And let's do a zoom so you guys will see that that is indeed the exact same signal. And it's exactly the same frequency because I measured the frequency. It's exactly 32.7 kilohertz. And I'm going to show you that in a brief second too, because that's something I can measure. You know, I love Picoscope because of that, you know. I mean, actually looking in another oscilloscope coming from Germany, but they cannot sell it into the United States yet. All right, so I think this is a good enough zoom so I can put, you know, I'm going to just put cursors for a 1 millisecond, around 1 millisecond exactly or so. So when I measure, I'm going to measurements, as you guys are seeing that, and I check on frequency. and then between the rulers. Right, we can see that there 32.79 kilohertz. So that is exactly, I know that's, I've been checking this really well. But and I'm going to now run the computer. So let me run this one. Oh, this is an 8.1, so I need to change the signal. So give me 1 second, because the other computer was a 5.7, which I have another 5.7 in here, but it's not open. So let me change the signal 1 second. Again, behind the scenes, you don't need to see this because it's not that important. I'm just changing my 5.7 signal to an 8.1 in my simulator. I can do that very quickly. Right, so that should be all good to go. I can take the zoom out of that. You guys not even seeing that. And let's run this one. And these dials are different. And this one is running. Let me just make sure the RPMs are okay. I'm gonna have to reselect that because it's a different MEFI. And we are connected. Perfect. And I have 726 RPM, so that is good. I can actually no, because it's not in a screen capture, I cannot show you that, but I can move you so you guys can see once, just a brief second where I am right now. And let me turn all this off and bring this down. So that is the computer running, and like I said, we got 726 RPMs, and you can see right here on the top. Let me just show you. This is an 8.1 liter. I had some trouble because I don't have all the ignition coils connected, but yeah, we got an 8.1 and it's 726 RPMs, as I said. All right. So we can see that everything that I mentioned to you in the video is exactly as it's happening in here. So it's going to keep you here. So when I change that, you just don't watching the screen. And so we're still there. Everything is the same. What else I was going to do? Oh, just show you the signals with the computer running. So I'm going to go over to those two signals because right now the fuel pump, and you will be a little far away, but again, you can see that red light right here. So I'm going to cover it right there. That is the fuel pump, and it's on. This is a good computer. That's an 8.1 Crusader. So if I go over to the fuel pump activation, we're now in zero, right? Because why? Well, the computer is running. I gotta go over to Vico. Almost try to do the same thing again. But yeah, so the computer is running, and we are definitely seeing 0 volts. Why? Because the fuel pump is on. So fuel pump relay on is going to be a 0, right? So it's a 0. Let me make sure I am not going to damage anything in here because these are expensive computers. But yeah, so that's the signal right there. So we got 0 volts, so the relay is completely actuated. And if I go over to that small path right there, right next to it, now we see that almost blue bar filling the screen. And the only reason it's showing like that is because of the zoom. I'm recording at 1 second per division. So that is a fast signal. So I remove the pin so I don't short nothing in the computer. But again, if we zoom in here, it's the same exactly thing that we had before. It doesn't change. That's a signal that does not change. It's a 0 to 5 volts. Again, let me just zoom a little more here. And if I put the same cursors in, and it doesn't matter where I put the cursors, as long as I get that 1 millisecond capture around there. Again, on this box that I'm moving in here, you can see the delta also one millisecond. And now you can see, sorry, on the bottom of the screen, 32.78 kilohertz. So that is exactly the same signal. The signal hasn't changed. The problem on the bed computer or Eric computer is that that is getting injected through the driver because it's not shorted under or nothing. No matter what I mean, that is a 5-volt reference. If I would be to inject a 12-volt, that would take over that signal and would drop the computer down. So this is not, it's actually internally in the driver. It's leaking out that signal, and that is keeping the driver from from actuating the relay. And that's why when I remove that connector from here and I put it back on, it locks the relay for a second. And it's not really fully doing it, because if I load a full relay, it will drop it, and that's why it doesn't work on the boat. All right, the other thing that I wanted to show you, and this is more for Eric than anyone. So let me go back to the main cameras. Let me just transfer you here. All right, so I'm going to turn this one off. All right, this is again. Let me move you over to the display so we can see how I lost the communication in there. I gotta adjust a little bit of the colors. I don't like the way those colors look in there. All right, guys, I was trying to correct that color because that was a weird color on the screen. So oops, I don't know what I did now. Yeah, hopefully it's not showing too much because I went into something that I shouldn't have not gone. All right, so let me see. Let me put you on the screen recording again. All right, so we're here. Let me just plug this back in the same computer, my same Crusader computer. I'm going to connect back in, and I'm going to let it lose the synchronization to make sure that the bar is now nice and green. That's a nice green color. That's the way it should be. All right, so I can just disconnect in here, and that's going to be the normal look. All right, so I'm going to one more time move this out of the way. You guys can see that I have let me move this camera. I'm not sure. I don't think that we need the microscope no more. I'm just going to disconnect this computer and keep Eric in there. Yeah, this one didn't tilt. This is mine cover. Yes. All right, so I have a good computer here. This is a 5.0, exactly like Eric. And I have you see it right there. It says Mike Salazar Diagnostics Good. This is a used computer, not repaired. It's just a very good computer. Very nice and clean. I opened it up myself just to make sure that nothing is burned or damaged. I mean, we don't need to really do much in here than that. So let me again move you over to the screen right here. Okay. We don't need the picoscope no more because I'm not going to be doing any more tests in here. This camera can go and that. So realistically, well, let me show you first activations. Fuel pump on and fuel pump off. That is also very good. I can also show you here. If I put the meter, I'm not sure why it's not there. The multimeter should be on. Oh, I know why it's not on, because I haven't opened it up. So give me 1 second. All right, now we have the multimeter on. Okay, so sorry guys, it's just too many things, right? I'm going to power the computer off again one more time so you guys can see how this 5 volts goes off. So I got the this meter connected over to, and it has a screen capture that I can use it on the screen. So that's how what I'm sharing with you. That is a Siglin SDM 3055. If you want to know, it's a 5.5 digit multimeter. Right, let me power the computer back on. Again, fuel pump on and fuel pump will go off. I'm going to lower the speed on here. So the 8.1 uses a lot more frequency compared to the 5.7. So computer is on. I have not established a communication with the scanner yet. So let me move you there. And let me take the meter out of the screen. So if I click on connect, it should connect because it's the same MEFI4. But we can see now the difference in here. All right, so now that's a 4.0 liter, right? Very good things. Look at right here. Start without malfunctions 5 times. That actually is really good. It's a very low hour computer. It has 283 exact hours. All right. So another thing that I need to do, since I did before, or the same way that I did before, I got to go over to my simulator and change the signal to the 5.7 or 5057 because it's a very different signal than the 8.1. So right here, and I just need to write this to my simulator. Okay, that's success. And then I just close this here, and we should be ready to go. All right, so let's run this up. And we can immediately see, RPM a little higher than normal. It should be around 700 RPMs. Throttle position on 5.9. That's very good. Now I start with all malfunction. You see how it went to 6 and also 0 trouble codes. So this is very important. I'm just going to keep things in here. So this is a very nice computer, Eric. I'm going to let you know, I have multiple computers in here. I didn't have a 5.0, and I'm always looking for 5.7s and 5.0, 5.0 Volvo Pentas. Those are the most common damage ones. I think the most problematic areas with the Volvo Pentas is the engine grounds. They get very corroded. The alternators are second most common problem. They damage the computers. They get shorted, and it takes all the ground circuits, the computer down. Leaking spark plugs with bad grounds on the block, it goes through the computer. That also damages. Bad injectors. I mean, I can give you a list of problematic areas definitely on these computers. All right, let me raise these up to around 4,000 RPMs. All right, and then I'm going to change the throttle, checking and see what I have. I'm going to move this a little bit out of the way, 16. So I'm going to go over around 30%, 35%, that's fine. Then move the map. And I want you to see, because this is very important. Well, yeah, we don't need to see that much. So I'm going to keep the throttle here too as well. Maybe here, right? Then the manifold air pressure. This is very important. This is one of the key players. And then I'm going to give you the injection milliseconds, because as soon as I change the map, the manifold air pressure, you're going to see how the injection millisecond is going to change. So I'm going to go from 12.5, which is an idle value, to around 17. And we can immediately see how the milliseconds of the injection change immediately. I have in here substituted value for the IAC. It's also working perfect. And as you see, we have 0 trouble codes. So this computer is a perfectly good working computer, so fully tested. It's a used computer. Again, you guys want to buy something new? Yes, they're very expensive. You still can find some, but they go up to almost $4,000, $4,200 for a new computer, right? And I don't know how new can that be, because they're no longer in production. I think it's like 3 or 4 years ago. So again, probably in the shelf, right? There was somebody that has bought a lot, or I don't know how they do it, but used ones, it's hard to find good used ones. That's what I open the computer to analyze and make sure the old pads. I'm a professional and an expert on these computers, so I know where the ground pads are damaged and stuff like that. That I will be like, yeah, this is a computer that I can use as a guinea pig, but not for sale, not to recommend to anyone to buy. But in this case, for Eric, I think that if you want to have a computer for yours, I'm sorry, but it's not repairable. I try my best. I have to spend hours and hours, and that's what I wanted to record this video for you and for all that has followed these marine testing and computers and everything. What I do here too, and show a little more, especially in his computer. But yeah, all right. So let me bring it down again to idle. I don't have the RPMs in there, but I can see it from here. So idle and in Volvo around 700 RPMs. That's very normal. And I'm going to bring now the throttle to around, it's in between 6 to 10%. And it is very, I don't know, they're very glitchy on the throttle reading. And that is very, very normal on this one. And I'm talking about the 2%. If you go and see the value of the voltage, it's not moving. And this is mostly software. Because I can show you here, like the voltage on the throttle. You see, it's like we're talking about, tenths of a volt. All right. So, but that is very common on these computers, even brand new. Okay. So let me bring the map and we'll see. Please take a look at, like, without changing the map, changing the idle, throttle position, and manifold air pressure are very in charge of the injection millisecond. Look, without changing the map, we have 3.4 milliseconds. So I'm going to bring the map to 12.6, which is what I use for testing, right? That's very unique in here. Very hard to be perfect on those. So around there, 1.7 milliseconds. So you see how throttle, manifold air pressure are the main key values for your injection time. All right, guys, and we already put a 10 of an hour on this computer. I hope that you guys like the content. I'm trying my best to give you different captures. Sometimes it's a little overwhelming for one person. Remember, this is a one-man show, right? So I'm trying to get my best for you. And I know that there's a lot of people asking me to record more videos on the shop. And I am definitely going to do it, but sometimes it's very hard, and then we're really busy, and I have to record videos also for the shop to get to the customers, and then now record another video for the audience. I'd make it very hard, but I promise that I will, because I know that you guys love to see those videos on working in BMWs and all the vehicles. So I'll definitely going to make that happen. Promise. Okay. All right, guys. Thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.